Namaste. Welcome to another video in our Kubernetes series. Today we'll understand Kubernetes architecture in detail but in very simple words. So let's get started.
Before diving into architecture, we need to understand few things first. What is a node? Now, a node is a worker machine, means it can be a physical machine or a virtual machine. But for simplicity, let's assume it's a virtual machine. Node is where the containers actually run. What is a cluster? If we just have one machine, which is a node, and that machine goes down due to any reason, then a site will be down and our users will be impacted. So to achieve high availability for a site, we need to have more than one node. Now to manage multiple worker nodes or worker machines, we need another machine which is called as control plane or control plane node. Now this machine controls the entire cluster along with the nodes. Together, control plane and the nodes form a cluster. Now here as well, for high availability, we can have multiple control plane nodes. But for simplicity, we'll consider it is just a one machine. Next, what is a pod? A pod is the smallest deployable unit in Kubernetes. Think of it as a wrapper around a container. A pod can have one or more container inside it, but generally there is only one container per pod. Now when I said node is where containers run, I actually meant node is where pods run. Now with this we have understood basic terminologies. Now let's see the Kubernetes architecture. Now this is the most important part of the video. So dial up your focus to 100% now. To install Kubernetes on a machine or machines, we need to install lot of components. It's not like a single software. Let's go through them one by one. We will also understand what happens when we run a command, how the request flows between all the components. Let's see all the control plane components first. Kube API server. This is the core element of control plane. It's the installation of this component that makes any machine a control plane. This handles all the communication between different components of the cluster and external components and also the end user, that is us. It exposes the Kubernetes HTTP API, which simply means Kube API server makes the API available to all so that the communication can happen between all the components. Yeah, Kube API server is a communication hub. HCD. Now this is the database of Kubernetes system. It stores the entire cluster state in a key value format, including details about pods, nodes, configuration, etc. Now this is a highly reliable, consistent and highly available data store. Kube scheduler. Kube scheduler decides on which node the pod will go. Means on which machine the pod should be running. Now this decision is taken based on various factors like CPU, RAM, etc. Kube controller manager. Now this component runs various controllers like replica controller or node controller and many more controllers are there. For instance, let's understand replica controller. Now replica controller is responsible to maintain the desired and the actual number of replicas. This simply means if we want 3 pods or 3 copies of our application to be running, then replica controller will take care of what we have desired for and what is the actual number of running instances. So that if 1 or 2 pod crashes, then this controller will bring it back to life. Cloud controller manager. This controller comes into picture when we use cloud managed Kubernetes service. Like if we need our traffic to be distributed using load balancer, then this component talks to cloud API and creates load balancer. Basically, it helps in integrating with cloud providers like Azure, AWS, etc. I hope everything is clear till now. If not, then please pause the video and go through it again because this is very important. If everything is crystal, then let's move. Now let's understand all the node components. Kubelet. This is an agent installed on all the nodes and its job is to ensure whichever pods are assigned to it are in running state and are healthy. Important thing to notice here is it only manages pods which are created using Kubernetes. Yes, we can create pods from external way as well, but then Kubelet will not recognize it. Next, Proxy. This is Kubernetes built-in networking component. This helps in communication between pods. It handles service networking, making sure traffic is routed correctly between pods and services. Some advanced network plugins can take over its role, but by default, Proxy is a part of Kubernetes. CRI or Container Runtime Interface. CRI is the one which does the actual work of creating the container. This is the employee that does the real execution of the work. For example, Docker is a container runtime engine. Kubernetes supports container runtime engines like Containerd, Cryo, etc. Now let me help you remember this through an example. We will take a very simple example. I will execute a basic command, and don't worry, we'll be learning all the basic commands of Kubernetes one by one. Now for now, this will be a simple one. Now to bring up a container in Docker, we do docker run. Similarly, to bring up a pod, we will write the following command: kubectl run nginx pod -- image equals to nginx. So this simply here means kubectl, we are using a tool to create the pod. Then we are saying run, and then nginx pod, this is the name of the pod that we are trying to give, and then we are calling the nginx image. When we run this command, an nginx image is pulled and an nginx container will be created inside the pod. Let's see how the flow goes when we run the command. This is a very simplified version, and trust me, the real version is super complicated. So as soon as we hit enter on the terminal, kubectl sends the manifest file which has pod details to Kube API server. Now Kube API server writes it down in the etcd, but the node field here is kept blank. Scheduler, which is constantly checking with the API server if there are any unassigned pods, sees this manifest and then assigns a pod based on CPU, memory, etc. Let's say it assigns node 01 to it. Now Kube API server writes this to etcd. Remember, only Kube API can talk to etcd. Now the manifest file has the required details. Kubelet from node 01, remember we assigned node 01 to it. So Kubelet from this node, which keeps on checking with Kube API server if it has any pod assigned to its node, and then it sees a new pod manifest is present which needs to be run. Now Kubelet asks CRI to start the container. Once it's running, Kubelet reports this pod status back to Kube API server, which updates the cluster state in etcd. In our case, we did not mention number of replicas. So by default, we will only have one pod running. But if we had mentioned replicas equal to 3, let's say 3, then controller manager and in that replica controller would have made sure 3 replicas are running at any given time. It keeps checking if the desired state matches the current state. Basically, desired state is 3 and current state, let's say if it is 2, then it will bring back another pod and it will make it 3. So 3 equal to 3. This was the complete flow. I hope this made more sense now.
Thank you for watching till the end. As usual, you can put all your doubts and questions in the comment section below. Next, we will see the installation of Kubernetes via Minikube. If you have Windows system, I already have a video on that on my channel. You can click on the I button and check. For Ubuntu and Mac, we'll be seeing that in upcoming videos. This is Pravanjan. See you in the next one. Until then, keep learning.